Hi friends, welcome to another lesson in the Network Address Translation Operations and Concepts module. In this lesson we'll be discussing static NAT. So if we pull up our definitions that we learned from the NAT terminology lesson, we know that a NAT is a modification of just the IP address, and we know that a static translation is an explicit mapping between the pre-translation IP address and the post-translation IP address. If we combine those, we then get a definition for static NAT as an explicit mapping between a pre-translation IP address and a post-translation IP address. The overall goal of a static NAT is to make an internal resource externally accessible. Let me show you how this works. Here we have a topology with an internal host with the IP address 10.22.33, and we also have an external host out there somewhere on the internet. If this is all you have, when this host tries to send a packet to the destination of 10.22.33, that packet will be dropped on the internet. Remember, there's a rule on the internet that says the only communication that can work on the internet is public IPs to public IPs. Since this packet includes a private IP address, this packet will be dropped as it crosses the internet. If, however, I have a resource on my inside network that I want accessibly externally, I would then have to configure my router with a static translation to make my internal resource externally accessible. In this example, I've configured my router to translate the IP address 10.22.33 to the IP address 73.82.33. Now, my external host can shoot a packet to the external IP address of 73.82.33, and this will allow the packet to cross the internet, reach the router, reach my internal resource, and my internal resource can respond. So that is how a static NAT works. Now let's pick this apart a little bit further. When this packet reaches my router, what the router is going to do is translate the destination IP address according to our configuration to 10.22.33. You'll notice the router didn't have to make any decisions. It simply saw this and therefore translated it to this. That's what makes it a static translation. Moreover, you'll notice the only thing that changed in this packet is the destination IP address. The only thing that changed is the layer 3 header. The ports did not change. That's what makes this a NAT. So hopefully that ties back together the definitions we learned in the prior video. Either way, when this packet then hits my internal resource will respond. When a response packet is generated, essentially the source and destination fields are reversed, which means what was the source in this packet is now the destination, and what was the destination in this packet is now the source. On the way out, when this packet crosses my router, the router will detect the IP address in the static NAT configuration. It'll therefore translate that source IP address to this IP address according to the configuration. Notice again, only the IP address information was modified, hence again confirming that this is indeed a NAT. So that is the basic operation of a static NAT. Again, it's an explicit mapping between one IP address to another IP address. Now, the technology of a static NAT doesn't actually care whether the addresses are private or public to public or private to private. It'll all work. The only general rule is that on the internet, you must communicate with public addresses. But you can absolutely configure a translation on a router of a private address to a private address. That's totally fine. Now, for the duration of these lessons, we're always going to be concerned with converting private addresses to public addresses, just because 90% of the time, that's what you'll be doing with NAT. Either way, if you followed along with the basic tenets of what a static NAT is, there are 3 more things I want to highlight about static NAT. The first has to do with what is being translated in what direction. Notice in the inbound packet, the destination is what was translated. We didn't change the source. The source stayed the same. We changed the destination IP address. On the outbound packet, the exact opposite happened. We translated the source. Notice on the outbound packet, what translated was the source IP. We didn't touch the destination. Generally, this is what you will see with NAT. With NAT, you're mostly concerned with what your devices are sending outbound. Therefore, on the outbound side, you translate the source, and then when the response comes back, you translate the destination. Keep this in mind because the majority of the NATs we're going to be discussing are going to do this exact same thing. The second thing we want to highlight with Static NAT has to do with who initiated the packet. In our example, the external host initiated the first packet, initiated this particular communication, and it worked. It translated through our configuration. But a static NAT would have also worked had the internal host initiated the conversation and the external host simply responded. They call this being bidirectional. A static NAT is bidirectional. It doesn't matter who initiated the host, the translation will work and it will apply. Now this is important because later on we're going to be looking at a different type of translation that is not bidirectional. So I want to highlight at this point that a static NAT is bidirectional. And finally, the last thing we want to point out about static NAT has to do with the original purpose of NAT, is that a static NAT does not conserve any IP addresses. Notice here we have one private address being translated to one public address. If we had another host on our inside network that also needed a static NAT, it would have to have its own public address. We would have a separate public address for every internal host that we wanted to create a static NAT for. As a result, static NAT does not actually conserve any IP addresses. Remember, we told you the original purpose of NAT was to conserve IP addresses, and you'll see that a static NAT does not actually do that. The goal of a static NAT was simply to make an internal resource externally accessible. A static NAT does not conserve address space. So those are the three items we wanted to highlight about static NAT. Hope you found this useful. The key takeaway from this particular lesson is that a static NAT is an explicit mapping between one IP address to another IP address. Hope you enjoyed this video, and I want to thank you for watching, and we'll see you in the next one.